Hello my friends, and welcome again to this ninth class in our chemistry series, into which, my friends, we are going to carry on answering the questions of 2024 British Person Edexcel International IGCSE. And as we know, my friends, we are going to go through the chemistry paper now, hoping that we are going to go through the English paper later. Today's class, my friend, we are going to answer question number 9. And question number 9, my friends, is about ionic compounds. So get ready, because today's class is going to be a little bit long, but it will include a very important revision for the things we have talked about in our previous course about the ionic compounds, the ions, the definition of ions, types of ions, how to make a chemical compound from the ions. Now, my friends, before we take this revision, let's read the question. The question number 9 here is the table shows the formula of some positive and negative ions and the formula of some compounds containing these ions. Now, my friends, the question is, complete the table by giving the formulae of the missing compounds. As you see here, my friends, we have a table. This table, we have horizontal fields. The horizontal fields include negative ions, or we call them anions. As we said before, we have two types of ions: the positive ions, here the vertical, and we call them cations. If you remember, my friends, cations are the positive ions, and as we remember here, the negative ions are called anions. And for cations and anions, we have also two types of ions. When the ion is made up of one atom only, like those, it is called monoatomic ion. Monoatomic ion means an ion that is made up of one atom only, while when the ion is made up of more than two or more atoms, of course different atoms, we call them polyatomic ions. Of course, whether they are positive or negative, they have another name, which is called chemical roots. We call them chemical roots because they stay together here, like this one and that one only, not this one. So, my friends, how to make a chemical compound? This question is very important, and we are going to answer it now. So, my friends, how to make a chemical compound here? How to make an ionic compound? We have here three main steps. Let's go through them. Step number 1, as you see here, always put the positive ions, or the cations as we called them before, the cations, put them left, while the anions, which are the negative ions, put them right. For example, we have sodium chloride, Na+, so the positive left, and the negative right, which is the chloride. As here we have calcium, the positive, and the negative goes right. We have two exceptions in our book. In this book, my friends, I'm going to teach you in this class, I'm going to teach you a lot of important, let's say, rules about ionic compounds, but they are not always true. These are true for our IGCSE book. When you go to the A level or AS, the A level or AS, you're going to see that some rules are not precise. They are true, but they are not precise 100%. So in here we have two exceptions in our book. This ion, which is called acetate, and this one, which is called formate ions. Those ions, my friends, are exceptions. This means that they come left, although they are negative. Generally, the negative ions go right, but because they are exceptions, they go left. So, number 2, we look at the numbers. Here, we look at the numbers of the charges. Of course, the charge of an ion is made up of two things. The first one is the sign plus the number. In here, my friends, when we want to make a chemical compound, we look at the number. The number is important. The sign is not important every time. It's only important to show the side, whether to go right or left. But the numbers are important in combining them chemically. So we look at the numbers. If the numbers are, here we have two options. Number 1, equal in absolute values. Again, my friends, here we have to pay attention for the numbers. We don't care for the charges. When we put the positive ion left and the negative ion right, we don't care for the positive and negative anymore. In the next steps, we care only for the numbers. We look at the numbers. So if these numbers are equal in the absolute value, what do we do here? We ignore both numbers and charges. For example, here NaCl, we have one. First thing, we ignore the signs, and the numbers are equal, so I combine them together with no numbers. I don't need any numbers. So here, ignore both numbers and charges and combine the compounds. Here we have a +2 and we have -2. Again, my friends, don't pay attention for the signs. As long as the positive left and the negative right, the role of the positive and negative classification is finished now. Now here we look at the numbers. So here we have 2 and we have 2. Again, my friends, if the numbers 3 and 3, if the numbers are equal, we combine them with no numbers. Here, combine, no numbers. Teacher, we have here 2 and 2. Shall I write 2 and 2? No. Shall I write here 3 and 3, teacher? No. Ignore the numbers and the charges as long as they are equal and they are okay. Now, in here, my friends, as we said, those are called ions. Those are called ions. That's why we care for positive, negative, and we care for the numbers. Here, we don't care for anything else. Those are called chemical compounds. So here, no numbers and no signs or no charges. Number 2 or B, if the numbers are not equal in the absolute value. In here, we have 3 things to pay attention for. First one is ignore signs. Again, my friends, we say ignore signs because the role of the signs, the positive and negative, ends or finishes when we order the positive ions left here and the negative ions right. So now positive and negative signs are not important. So forget about the signs after you classify them into positive and negative. Now, exchange the numbers. Here, we need to exchange the numbers. How do we exchange the numbers? For example, I have here oxygen. Let's concentrate on one example. We have oxygen. What is the charge of oxygen? It's -2 as you see here. So we exchange. This takes 1 and this takes 2. Again, ignore the signs. When we combine chemicals, we don't look at signs. Signs are not important. So we have Na2, as you see, because Na takes 2 from the cross multiplication, and oxygen takes 1. Shall I write 1 here? No, I don't have to. If the number is 1, we don't need to write it. Now, my friends, let's carry on here. We have Ca, Cl. Ca is +2, Cl is -1. We exchange them. So the Ca takes 1. Shall I write 1? No, I don't need to. For chlorine, I shall write 2 here. And again, we have Al. This is Al +3 and S -2. We have to exchange them. The Al takes 2 from the S and the S takes 3 from the Al. Now here we have a problem, teacher. Teacher, look at this chemical ion, this SO4. SO4 is not one atom. It's a group of atoms. Those are called polyatomic ions, or we call them chemical roots. Both names are correct, these names. So what shall I do? Shall I write the number here, for example? This SO4 takes 3 and Fe takes 2. Shall I write the number here, for example, teacher? Shall I write the number 3 here? No, this is not going to be logical. We need to understand the definition of the chemical root. What is a polyatomic ion? If we understand the definition of a polyatomic ion, we are going to understand why do we have to use the parentheses. A polyatomic ion is 2 or more atoms that refuse to be separated and become one ion. And here, and let's say insist to be one or to become one ion. So this here, my friend, this SO4 is 5 atoms, 1 sulfur and 4 oxygen, but we deal with them as they are like 1 Cl. So when this chemical compound FeSO4 here, when we want to combine it, we take 3 of all of SO4, 3 of it and 2 of Fe. That's why when we write the chemical root and we need more than one, the number is more than 1, we put it into parentheses. So Fe here, Fe2 and SO4 3. So this 3 is multiply with the O4 and with multiply with the S. Teacher, is this important? Yes, it's very important, and you're going to recognize its importance when you take the molecular mass and the other chemical equation. So this is very important. If you don't understand it, please, my friends, go back to my course, Mr. Odate Chemistry course, and you're going to get a deeper explanation. Again here, my friends, we take NH4, which needs 2, CO3, we need 1. As long as we need 1, we don't need the parentheses, but here, this is a chemical root, positive chemical root, so we need parentheses, and we add number 2. We have aluminum, SO4. For aluminum, SO4, we need 2 from here for aluminum and 3 for SO4. Here 3 and here 2. Calcium phosphate, again, we need 3 here and we need 2 here. So this is 2 and this is 3. I cannot explain it simpler because that is the simplest I can explain. Now, my friends, let's go to the question. As you see here, my friends, the question is complete the table giving the formula of the missing compounds. Let's see here. We have this one and this one. So we have Na, which is +1, and we have Cl, which is -1. Again, positive ion goes left, negative ion goes right, as long as we don't have formate or acetate. And then we look at the numbers. Here, this is number 1. So as long as the numbers are equal, we combine them together without looking at the numbers. So the formula will be NaCl. Now, let's explain this one here. So we have oxygen, and oxygen is -2, and we have, this is Na, which is +1. We exchange them. We need 2 sodium and 1 oxygen, so the numbers are here given. As we see, the oxygen takes 1. Now we take Zn with oxygen. Zn is +2 and oxygen is -2. Again, my friends, when the numbers are equal in the absolute value, we only need to write the Zn. Oh, do we need to write here 2 and 2? No, because we ignore both charges and numbers as long as the numbers are equal. The second question here, my friend, inside the question 9 is give the name of the compound of the formula ZnSO4. I see like the video is now very long. In the next video, my friends, I'm going to answer the question of how to name, as you see here, how to name ionic compounds. See you in the next class.